All right, section 5.2, we're going to be multiplying rational expressions. One of the nice things about this lesson is if you can go through it and understand what we're doing, there is another section called dividing rational expressions. And in order to divide rational expressions, you need to know how to multiply them first. So if you can do well on this, then dividing is not really that much more difficult. It just requires one extra step, which isn't tough to do. But the main idea today is that we're going to get fractions. Sometimes it'll be a fraction times a fraction. Sometimes it'll be a fraction times a whole number or something, or a whole term. And we'll kind of do a little bit of both today. But we're going to work on just multiplying things out. Now, I want to make sure you guys remember a basic property here. Okay? So when you multiply fractions, I'm going to put right here, multiplying fractions. So A over B times C over D is AC over BD. Okay? You multiply straight across. Don't go diagonally. You can cross cancel diagonally. But if you're just going to multiply, you're going to multiply straight across. Now, most people know this and they don't have any problem with this. But then there's this type of problem. And for some reason, students sometimes mix this up. So when you multiply this way, it's AB over C. Now, my daughter, my youngest one, messes up a lot, and she always does AB and AC on the bottom. She multiplies the big term times top and bottom. Like, no, the term itself always multiplies up. Okay, always multiplies up. So I just want to make sure you guys know that these are supposed to be like common knowledge, but you know, common knowledge isn't very common sometimes, right? So I'd rather review it with you instead of you wondering like, what did he just do and how did he do that, right? Let's just go over it again. When you multiply two fractions, you should multiply straight across. Numerator times numerator, denominator times denominator, okay, when you're multiplying. If you're multiplying a fraction times a whole term, then that whole term multiplies up, not to the bottom, okay? So it's just the term times the numerator only, okay? Leave the denominator alone in those cases. So, like I said, this is more of just like a safety net. Okay, I'm just trying to put a safety net there. That way you guys don't accidentally multiply things wrong and then you end up doing all this weird stuff and wondering why these things are so difficult to do. Some will be difficult to do. I'm going to tell you that because they do require a lot of extra work. And you'll see it right when we do it today. So like I said, I'm hoping to do about 6 examples, varying from easy to difficult. And the difficult ones will take time. Okay, they're not going to be super fast. So, all right, here we go. So we'll start off with some easy stuff. So we're just going to simplify. Okay, the whole set of examples I'm going to do, they're all under this umbrella of simplification. So example number 1, we got 7 over 8n times 2n. Okay, so 7 over 8n times 2n. Now, sometimes people tell me, well, can I rewrite the 2n as a fraction? Yeah, you could. If you want to, you can rewrite it as 7 over 8n times 2n over 1. And the reason why they want it as a fraction is so that they know the 2n multiplies the 7, the 1 multiplies the 8n, right? You don't have to do that, but you could. So if we go ahead and multiply across, you know, we'll get an answer. But sometimes I'm going to show you a different way to do this after. But let's go ahead and multiply 7 times 2n, that's 14n. And then 8n times 1 is 8n. Okay? Now, if you look, I can simplify that, right? Let's think about the numbers themselves. 14 and 8. What number divides a 14 and an 8? A 2. So let's reduce this by 2. Okay? So 14 divided by 2 is 7. 8 divided by 2 is 4. So my new fraction will be a 7 over 4. What about n divided by n? What happens to that? They cancel out. So let me just kind of change the color here. That way you know that was a whole different step. So all that's basically left is 7 over 4. And that's it. You're done. Okay? Now this is one way of doing it. If you want to see another way, we can do it another way. So if I have 7 over 8n times 2n. Remember, if you want to write it as a fraction, feel free. But there are some people who are okay doing this, right? Some of us feel confident cross-canceling. You could cross-cancel n with n diagonally. By the way, you cannot cancel straight across. It's either above and below, so vertically, or diagonally you can cancel. Okay? And then you see how there's a 2 and an 8 there? So 2 goes into itself by dividing by 2 one time, and 8 divided by 2 is 4. So basically my new fraction looks like this. 7 over 4 times 1 over 1, which is 7 over 4. I don't know which way you guys prefer. I know I prefer the one on the right, because I like to cancel stuff out before I do my multiplications. That way my numbers don't end up big, right? My numbers I don't have to multiply a 5 times 10, right? I can reduce before I do my multiplication, okay? But some people don't like that, and that's okay. You can do it the way on the left. Multiply first, cancel out next, okay? Whatever you prefer, that's up to you, all right? Like I said, some people feel like, I like the right side best, because I'm used to cross-canceling, so I feel comfortable with that. And if you do it, because it's going to make it seem a little easier. But if you don't, do the left side. Multiply first, and then cancel out later. It doesn't matter which way you do it, guys. You're going to cancel out no matter what. Either way, you cancel them. And you're going to multiply either way on both sides. So you're still doing the same 2 steps. So it's not like, oh, if I don't do it the way on the right, I'm going to take longer. No, you still have to do the same amount of steps. Okay, so don't feel like you have to do the way on the right. You can do the way on the left, and that's fine. Okay, whatever you prefer. So again, that was one of like the easier types. Let me show you another one that's kind of like on the easier types. So example number 2. Remember, these are all homework problems. So 4x over 6 times 8 over 9. Now I'm going to do this one both ways again, just so you can see what it looks like. And you just choose whichever one you feel comfortable with. So let me rewrite the problem here. 4x over 6 times 8 over 9. Now doing it the old-fashioned way without worrying about canceling anything, I'm just going to straight out multiply 4x times 8. That's 32x over 6 times 9. That's 54. Okay? Well, now I got to think of numbers that go into 54 and 32. 54 and 32. Well, let's see. Factors of 32 are 1 and 32, but 32 doesn't divide 54, so I'm not going to use 32. 16 times 2 is 32. Does 16 divide 54? What's 16 times 3? If I do this, or I'm sorry, not 16 times 3, 16 times 4. I think that's what I'm looking for. Yeah, this is going to be a 4, but then this 2 goes here, so that's too much, right? That's too much. All right, what else divides 32? 8? Does 8 go into 54? No, 8 times 7 is 56. What about 4? 4 goes into 32. Does 4 go into 54? No. It doesn't go in, right? Like, it'll go in once at first, and that's going to give you a 14, and that's not going to go in. So the only number that actually goes into both of these is 2. Right? Notice, if you're wondering, why did I go backward from the high numbers to the low numbers? If you reduce by the highest numbers, you get done faster. Okay? So I went from high numbers, so I did 32, I did 16, I did 8, I did 4, right? 3 does not go into 32, but 2 does, right? So let's reduce by 2. So 32 divided by 2 is 16. And 54 divided by 2 is 27. All right. And there's nothing for me to cancel out the x's with. So my answer here will be 16x over 27. And remember, if you have those nice calculators, like you can always borrow the ones that I have if you want. I'll bring them out for you. You can just type in 32 over 54 and it'll reduce it for you, okay? So you don't have to like do it in your head. I'm just doing it in my head because I don't have my calculator in front of me. All right, so there you go. We're done. Here's my answer. And if you want to double check, ask yourself, does 16 divide 27? No, right? We're going over the factors of 16. Does 8 divide 27? No, it doesn't. What else? 2? Well, no, because it's divide 27. Right? 4 doesn't divide 27. So none of the factors of 16 will reduce anymore. Okay? So we're done. Now, if you want to do it the other way, where you try to simplify first. It gets a little messy, but here we go. Just take your time with it. Okay. 4 and 6. I can reduce those by 2, right? So this will be 2x over 3. Okay? So I can reduce first. Now, can I reduce 8 and 3? Can I reduce those? No, they don't go into each other. Does the 2 go into the 9? No. Does the 8 go into the 9 somehow? No. And what about the 2 over 3? Do those go into each other anymore? No. So that means I'm actually done simplifying my numbers. Let me go ahead and multiply. So 2 times 8 is 16. And there's an x on top. And 3 times 9 is 27. And there you go. Notice I didn't end up with that 32 over 54. Remember I told you people who like to cancel early would prefer not dealing with bigger numbers? That's what I mean. I'd rather not deal with 32 over 54, so I'd reduce early. But thanks to the wonders of calculators, you can just have the calculator do the hard work for you, right? Just type 32 over 54 and it'll give you 16 over 27. But when I was your age, I didn't have a calculator that did that really cool stuff, right? Mine were, the calculators I used were the equivalent of the calculators you get in the McDonald's Happy Meals that look like a French fry. And basically you can only add, subtract, multiply, and divide and take a square root. That was pretty much it. It didn't have anything special in it. So I had to know how to break things down, right? You guys don't have to. You can use a calculator. Are we okay with this one? So I mean, pretty straightforward. Nothing really to worry about. And then they throw something like this at you. And you're like, okay, things are starting to get a little more interesting. Example number 3. So 3b squared times b minus 2 over 4b times b minus 2 times b minus 2. By the way, in your homework problem, they don't actually use a parenthesis there. They just leave it like that. But anytime I see a binomial, I always like to put parentheses around it. So that b minus 2, I'm going to put parentheses around it. Okay, so let me rewrite this. I always like to rewrite it because I'm about to like scratch it all up. So I don't want to scratch up the original problem. So 4b, b minus 2 times b minus 2 over 3b squared. Okay. I could multiply everything together if I want, okay? Everything together. But I'd rather try to get rid of stuff first, because then I'm going to end up with a bunch of junk that I got to try to figure out how to break down. Why don't I break stuff down now that I can see it? So, what can I cancel out? What looks obvious to you that I can cancel out? The b minus 2. Now, I can either cancel it out like this, here and here, or here and here. Either way, it doesn't matter. Okay? I can do that. So those are gone. What else can I cancel out? The 3b squared on both top left and bottom right. I can actually get rid of the 3 with this 3, the b squared with this b squared. Is there anything else I mean, if right now you're having a hard time seeing, sometimes maybe rewrite it. So let me rewrite it based on what I have now. I have a 1 on top because notice there's nothing else there. A 4b, bless you, times b minus 2 over 1. That's what's left. Can I cancel that b on top with the b on the bottom? What did I tell you yesterday about doing that? The only way you can get rid of the b and the b minus 2 is if you have a matching piece, and we don't, right? So I'm done. I just got to put that together now. So here we go. This is b minus 2 over 4b. And that's it. That's the answer to this question. So this is why it's good that you cancel early. Because if you don't cancel early, then sometimes you start working out all these big old pieces and it's a lot of stuff. Right? It's a lot of stuff and it might get you a little confused. So sometimes better to just chip away a little bit and then rewrite and then maybe continue to chip away a little bit until you finally get something that cannot be simplified. So there's example 3. Any questions on that one? Just be careful, guys. Like that's the whole thing about math. Everybody wants to get it done so fast that sometimes you're just not being too careful and you make mistakes and then you don't know what's going on. Yesterday I had one of my BC students show up after school and they were like, I don't know what I'm doing wrong. I was trying to do this problem and I can't get the right answer. So I was looking at his work and he was explaining it to me. And I'm like, you made a really simple error. And they're like, what? And I'm like, yeah, 2 plus 3 is 5, not 6. And they're like, I was rushing. And I'm like, yeah, it happens. When you rush, sometimes you make little mistakes, right? You misread something. So, just take your time with it, okay? I know this stuff can sometimes be annoying because you're like, yeah, but these problems take a long time. But I'll be honest with you, it takes even longer when you make mistakes and you have to redo it again, okay? So take your time, do it right the first time, and you should have better results. All right. So I'm going to rewrite it, okay? Just so I can mess with it. (20x plus 24). 20x plus 24 over 4x plus 8. All right. Is there anything that's obvious to you that looks like I could just cancel out? All right. So the 20x plus 24 diagonally, right? I can get rid of those. So let me get rid of those. Is there anything else that looks obvious to you, like I can get rid of this? I mean, if there's not, it's okay. But I would say right now, nothing looks like it's super obvious. Okay? So what if I just rewrite it right now? Let me just rewrite this. So 8x plus 16 over 1 times 1 over 4x plus 8. I'm just going to rewrite it so it doesn't look so confusing. Now, can I do something to the top left side? Remember, all we did was factoring for the past 4 days, right? Can I factor 8x plus 16? What can I take out of it? An 8, right? I could take an 8 out. So let me do that. Let me make sure I get the right color here. Let me take an 8 out. That becomes 8 times x plus 2 over 1 times 1 over... What about the bottom right side? Can I factor that at all? What can I factor out? A 4, so this will be 4 times x plus 2. Is there anything I can cancel out? X plus 2s, that looks like it's a pretty obvious cancellation, right? Anything else? Maybe I can't cancel it, but can I reduce? Yeah, right? 8 over 4. How many times, or what number reduces 8 and 4? A 2, but there's even better. A 4, right? So 8 divided by 4 is 2. 4 divided by 4 is 1. So look what happened to this big old fraction that I gave in the very beginning. Look at what it has become. 2 over 1 times 1 over 1. After simplifying everything, this is basically the fraction we're left with. So 2 over 1 times 1 over 1, well, that's just 2 over 1, which is basically 2. So that big old mess was just 2. Again, just take your time with it. If you have to take extra steps rewriting stuff to clean it up so that you can actually see it a little better, go ahead and do that. You know, I've been doing this for over 20 years. So for me, I don't care about marking up everything and factoring in between and scratching everything up, and then from all that, understanding what I did. Because I've done it for so many years, it's just normal practice now, right? It's like riding a bike. I don't have to relearn it. It's pretty easy to do now. But when I first was doing this, it wasn't like that. I had to chop little pieces at a time and then rewrite. What else do I see? Oh, I can factor this. Let me do that. Let me do that. Now I can chop these pieces. What else do I see, right? Little by little, I would get there. But the more you practice, the faster you get, right? So that's how we get this answer right here of 2. So notice it's getting a little bit more challenging. We got 2 more to go. The last one is supposed to be kind of like the hardest one. But actually, that's a lie. One of them that I didn't do is actually the hardest one, but I don't want to do it for you guys because I want you guys to have fun with 2. I don't want to have all the fun, right? So example number 5. But the one I'm going to do at the very end has a little trick to it, and I don't want you guys to do the trick without ever even seeing how to do it. So I want to show it to you guys. So this is k plus 10 times k plus 10 over 3k squared plus 30k. Now notice how the top right has a k plus 10 in it, but it's not in a parenthesis, but it looks like it's as simple as it can get, right? So I'm actually going to put a parenthesis around it, okay? Can I cancel the k plus 10 and the k plus 10 side to side? No, right? You're not allowed to cancel sideways. You can cancel diagonally, you can cancel vertically, but never side to side, okay? So sometimes we get a little, I guess, excited to see that, and we're like, oh, get rid of those, right? But no, not side by side. Now, let me rewrite it because I'm going to do something to it here. This is going to be k plus 10 times k plus 10 over 3k squared plus 30k. Like I said, I like to rewrite it because I don't like to mess with the original problem if I can avoid it. So, can I factor anything out of the k plus 10 on the left side? No. What about the k plus 10 on the top right side? No, right? What about the 3k squared plus 30k on the bottom? What can I take out of the 3k squared plus 30k? A 3 and 1k, right? So let me rewrite this. K plus 10 times k plus 10 over 3k, that's what I'm factoring, k plus 10. What can I do here? Cancel out k plus 10. Can I only cancel out the one on top and on bottom, or can I also go diagonally? Yeah, I can go diagonally too. So you can choose. If you want to go this one and this one, feel free. If you want to go this one with this one, it's the same thing. Okay? Let's just go diagonally, just for fun here, not doing what most people would naturally do. Let's do something like that. All right. Well, I'm done canceling. Can I cancel out the k in the k plus 10 with the k on the bottom? No, right? If I want the k plus 10 to go away, I better have another k plus 10 on the bottom, which I don't. So, final answer for this one, k plus 10 over 3k. So this last one is going to take us a little bit of time. Like I said, these are one of the tougher ones, so you'll see why it's considered a tougher one. But the really hard one that I didn't do for you guys, you're going to have to do the X method 3 times within the problem. Okay? We're only going to do it once right now. But you're going to have to do the other one 3 times. It's not like they're hard things to factor. But yeah, to have to do the X method 3 different times because each piece has three terms, it gets a little annoying, right? So this is what I mean by you got to be patient, take your time. So last example here, example number 6. So remember, these are all homework problems, so you guys should be able to at least have 6 out of the 14 done. You just got to do 8 more. So here we go. This is 35p cubed plus 21p squared over 4 minus p times p minus 4 over 15p squared plus 9p. So notice I'm not doing any X method in this problem. But the hardest problem in the homework has X methods, I think, on the top left, top right, and bottom right. Okay, so you're going to have to do that 3 different times. But I mean, we've practiced it, right? So it shouldn't be anything you should be scared of. Just maybe not happy to see. Okay. So is there anything that looks like you should be able to cancel out just straight away? Can I cancel out the p minus 4 and the 4 minus p? No, right? What if it was p plus 4 and 4 plus p? Could I cancel those out if they were adding? Yeah, because addition you can add in any direction and it's the same thing. But subtraction, you can't just, 2 minus 3 is not 3 minus 2, right? One is negative 1, one is positive 1. So I can't just cancel those out. But I can manipulate them, and I'm going to show you the manipulation. This is why I'm doing this problem, because if you see another one like this where you're like, man, it almost matches, but it's a minus, I wish I could just flip it. Well, you can, but you got to do something special with it. So let's start off with the top left corner of that equation. What can I take out of 35p cubed plus 21p squared? What number can I take out? A 7, all right. And what about letters? A p to the second, right? Because one of them has 3 p's, the other one has 2 p's. So a p to the second, all right? So that leaves me with 5p plus 3. Okay, that's what's left over. Now, to make the bottom left match the top right, I'm going to flip it, p minus 4. Okay, but if you do that, because you're actually not allowed to do that, just flip it. If you put a negative outside, like that, then you can flip it. Okay, because notice, if I distribute that negative in, isn't that a minus p plus 4, which is 4 minus p? Okay, so it's the same. So if you're going to flip a subtraction, you're allowed to, but just make sure you factor a negative out. Okay, you got to factor a negative out. All right, so that was one little trick that I'm not sure if you guys knew about, but if you didn't, now you do. The top right, there's not much I can do with that yet. And then the bottom right, what number can I take out? A 3, and what letter? A p. So 15 divided by 3, that's a 5, and then p squared divided by p is a p plus a 3. All right. So we're in a good place right now. What can I cancel? 5p plus 3. All right. What else? P minus 4. All right. Anything else? One of the p's, right? See how there's a p squared on the top left, and there's a single p on the bottom right? Okay, so you know what? Let me not do that at the same time. Let me take the extra step here. For those of you guys who are like, no, why? It's just, I'm looking now and I see some people being like, I don't know what you're talking about, the extra p's there. So let me just rewrite it. This is what's left over right now, okay? So now you see how there's a p squared on top. There's a p to the first on the bottom. The top has 2. The bottom has 1. So I can get rid of 1 from each. So this will become a first power, and that will disappear. So if I multiply across, Or if let me just rewrite it one more time. Here you go. And I multiply across, I get a 7p over negative 3, or I can just put the negative in the very front. Negative 7p over 3. And this is what your homework's going to look like, guys.